Hi students, today we're going to continue learning about probability. At the end of this lesson, you should be able to count the number of ways to arrange letters or items using factorial. Let's go ahead and start with this warm-up. So how many different ways are there to arrange the letters in these words? Go ahead and try these ones by writing out all of the ways. Okay, let's do it together, starting with car. So first I can write this as C-A-R. I can do C-R-A. Those are the only ways to do it with the C first, so now let me change it to R-A-C, and then R-C-A, and then putting the A first, I can do A-R-C, and then A-C-R. And you can double check, but it looks like these are the only ways to arrange C-A-R for car. So how many ways are there? 1, 2, 3, 4, 5, 6. So there are 6 ways. Okay, and we'll do the same thing for fish. So I'll start with the F, so I can do F-I-S-H. And then keeping F-I, I can change these, so H-S, F-H-S-I, F-H-I-S, and then F-S-I-H, F-S-H-I. That's starting with F. Starting with I can arrange it this way. These are all different. None of these are repeats so far. I can do S, and it looks like I need to do the last one starting with H. So I can do H, F, I, S, H, F, S, I, and then keeping the H, I can do H, S, I, F, and then H, S, F, I, H, I, F, S, and H-I-S-F. Okay, so counting up all of these ways, I have 6, 6, 6, and 6, so it looks like there are 24 ways to arrange the letters in fish that are all different ways. None of these in here repeat. So you can see as the number of letters, as the word gets longer, there's more ways to arrange the word. So you can imagine trying to do daughter and delight. This would probably take us a very long time to write out all the possibilities of arranging those letters. So as you're thinking about this, you should be thinking of any shortcuts we might see between how many letters there are in the word, and then how many ways to arrange it. Let's go ahead and do the next example. So this is mom, and notice what's different about in this example is that there's a letter that repeats, the M. So in order to list out all of the ways here, I needed to color code them like this. So I can write M-O-M, just like it's sitting with the blue M here. I can do M-M-O, noticing where the blue M is. I can start with an O and do it O-M-M, both ways here. Oops, and this one, let's make this one the blue one here. And then I can put the blue M first and do it that way. So when you have a letter that repeats, you can see color coding it, it looks like there's 6 different ways. However, some of these ways are repeats because M-O-M here, starting with the black M, is the same as M-O-M here. So we really can't double count in this case. Same with M-M-O and M-M-O. Those are the same, so we shouldn't double count. So in this case, the number of ways, we would count this as one way, this as the second way, and this one here as the third way. So there really are only 3 ways to write mom because of the repeating letter. So we're looking for some kind of connection, something that could make this easier for us, because now if we needed to think of how many ways there are to arrange Mississippi or necessary or Honolulu, it might take us a really long time to do this. So looking back here at car and fish, let me point out a couple of things here. So for car, there's 3 letters. So when there's 3 letters, there were 6 ways to arrange them. Think about any connection you can see between 3 letters and 6 ways, or the numbers 3 and 6. Now when there's 4 letters, there are 24 ways. And what I'm getting to here is that we can find a shortcut by using what's called the factorial. Some of you might have heard about factorial, others of you haven't. Basically what that means is that we're going to take the number of letters, so in this case there's 3 letters, and you just multiply it by the descending numbers to 1. So 3 times 2 times 1, which gives you 6. Now for 4 letters, same thing, you take the total number of letters, factorial. So this would be 4 letters, so 4 times 3 times 2 times 1, which is 4 times 3 is 12, times 2, which is 24. So this is something we would just have to catch on to the more problems we do and the more arrangements we make. So let me make sure you guys got that down in your notes. So this is called factorial. You can see all these exclamation marks around the page. These exclamation marks in math, they mean factorial. In English, they might mean something else, but when you're in math class, this is read as factorial. So n factorial, that means the product of all the whole numbers from from 1 to n. So for example, if you had a word that had 7 letters in it, the number of ways to arrange it would be 7 factorial. If you write it like this, this means 7 times 6 times 5 times 4 times 3 times 2 times 1. You plug those numbers into a calculator and you get a really big number there. If you had a word that had, say, 22 letters in it, you would do 22 factorial, plug those numbers into your calculator, it would take a while here, all the way down to 1, and you would get your answer. If you Google it or use a bigger calculator, there's actually a button that you can press for factorial. So going back here, if we did have to arrange daughter, all we would do, we would count up the number of letters, 1, 2, 3, 4, 5, 6, 7, 8 factorial, 8 letters, and just do 8 factorial. So this is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Give me a minute and I'm going to plug those into our calculator. So we have 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. We get 40,320. So what that means is if I asked you to do this by hand, you would end up writing down 40,320 different ways to arrange daughter. So note that this is when the letters do not repeat. So let's go to our other example here. So with mom, we saw that we wrote down 6 ways, but there were some repeats here. The letters that repeated was just the M. So if we think of our shortcut by counting up the number of letters, so there's 3 letters total, you would think we would just do 3 factorial, which would be 3 times 2 times 1, which would give you 6. But because one of the letter repeats, we actually need to divide that out by how many repeats there are. So since there are 2 M's, we need to divide by 2 factorial. So in this case, 2 factorial is 2 times 1. So 6 divided by 2 is just 3. So let's see how this applies to one of these really big words here. Let's try for necessary and see how that one would work out. So in necessary, it looks like we have 1, 2, 3, 4, 5, 6, 7, 8, 9 letters. because there are 9 letters, we would do 9 factorial. However, some of these letters repeat here, so we have to divide those out. So 9 factorial divided by the letters that repeat. So we have an E that repeats. How many times does it repeat? 2. So we divide by 2 factorial. There's another repeat. There's also 2 S's right here. So we also need to divide out those S's by doing 2 factorial since there are 2 S's. N, C, A, R, and Y, none of those repeat. So we can work this out. 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 2 times 1 times 2 times 1. So working out that really big number, you can see in the calculator, 9 times 8 times 7 times 6 times 5 times 3 times 2 times 1 is this number. So we'll write that down, 3, 6, 2, 8, 80 divided by 4, because 2 times 1 times 2 times 1. And we end up getting 90,720 ways, different ways to write necessary. And to make sure we have this down in our notes, you guys can write this down as the rule or the pattern we just saw. So if there are no repeats, we're going to use n factorial, just the total number of letters in the word. If there are repeat letters, we need to use n factorial, the total number, divided by the number of each letter that repeats. Okay, try these 3 examples and I'll see you tomorrow.